Hi, this is lesson 25 of Module 4 for 8th grade math. We're going to talk about the geometric interpretation of the solutions of a linear system. So in the last lesson we learned what a system of linear equations is, also called simultaneous linear equations. And today we're going to look a little bit deeper into the geometry of it, and you're just going to get a lot of practice looking at systems of equations and graphing them and kind of analyzing their solution. Okay, so in this first exercise here, we're going to go through 5 exercises together, and then you'll be ready for the problem set and exit ticket. So remember, this notation here means that this is a system of equations, that any solution has to be a solution to both equations at the same time. That's why we also call them simultaneous linear equations. Okay, so we're asked in this first part to sketch the graphs of the linear system on a coordinate plane. So whenever we have a system of equations, we just use one coordinate grid to graph them. So let's look at that. So this first equation here is not in slope-intercept form. So what I'm going to use is I'm going to graph that by its x and y intercepts. So first I'm going to let x be 0. So I would have the point, if x is 0, I would have the point, I would be left with 2y is equal to 12, so y would be 6. So there's one solution to that first equation. This is going to be my purple equation here. And then the x-intercept is the point where y is 0. So when y is 0, if I let y be 0, then this term becomes 0, and my equation is x equals 12. So I would have the point 12, 0 and the point 6, 0. So I can go ahead and graph those. I mean the point 0, 6 right there, and the point 12, 0, which is right over here. Okay, so I got those 2 points, and I can graph the line in between them, if I can get it going here. Pretty close. Okay, so let's switch colors and we'll do another graph. We'll go green. Okay, so this is going to be my green equation. This equation is in slope-intercept form, and so I can see that the slope is positive, it's 5/6, and the y-intercept, b, is -2. So I can go ahead and graph the y-intercept. So the strategies I use to graph an equation can be based on the format of the equation, whatever form it comes in. So I'm going to plot my y-intercept of -2, and then I'm going to get the next point by using the slope. So I know that if I go over 6, whoops, that's not the one I wanted to use. If I go over 6 and up 5, 1, 2, 3, 4, 5, I can find my next point, which, oddly enough, is a point on the other line. So that's kind of a good thing. So I can graph my line right through there. So I used graphing by point and slope, and I used graphing by 2 points on these 2 equations. Okay, so part A says name the ordered pair where the graphs of the 2 linear equations intersect. And so I can see that that ordered pair is at 6, 3. And it looks like it is exactly at that point. 6, 3. Okay, so let's look. Let's keep going. We'll write it down again. It was at 6, 3. Part B says, verify that the ordered pair is a solution to 2y plus x equals 12. Remember, that was our first equation right here. 2y plus x is 12. So we're going to show that this ordered pair is a solution there. So I'm going to substitute 3 for y. So I've got 2 times 3 plus x, which is 6, equals 12. And this is 6 plus 6 equals 12, so it checks out. So 6, 3 is an order, that ordered pair is a solution to the first equation. So now we'll verify that it's a solution to the second equation. So for y equals 6x minus 2, we'll put in 3 for y is equal to 5/6 times our x value. Remember, here's our x value of 6 times 6 minus 2. Okay, so we've got 3 is equal to, now 5/6 times 6, the 6 over 6 is 1, so this just becomes 5 and then minus 2, which I can tell is 3. So 3 equals 3, so it this ordered pair 6, 3 is a solution to both of our equations. And so we found that by graphing it. And we saw in the last lesson that you can't always be super accurate on these graphs, but when they do cross at grid lines, then it's a little easier. Okay. So there you go. So let's look at another one. Okay, so this goes with example 1. Could the point 44 be a solution to the system of linear equations? That is, would 4 make both equations true? Why or why not? Well, I'm going to go back and look at the graph and look at that point 4. The point 4 is right here, and it appears to be a solution to the first equation, 2y plus x equals 12, but does not lie on our second line, y equals 5/6x minus 2. So we can check it, but we could say, no, it's not a solution to the system of equations. So if I check it in 2 times x plus y equals, it was 8, right? 12. 2y plus x equals 12. 8 plus 4 equals 12. So it checks out for the first equation, but our second equation was y equals 5/6 x minus 2, and we would have y is 4 and x is 4. So 4 times 5/6 would be 26 minus 2. Going to express it as 6, which would be 12/6. So we're asking ourselves, is 4 equal to 8/6? Whoops. 8/6. 20 minus 12 is 8. We're working with 6. 4 does not equal 8/6, so it's not a solution to that second equation. So, so the answer is no. And why or why not? Because I checked it and it's not a solution. Okay, so you have more room than I do, so you could answer that. Okay, let's look at number 2. Sketch the graph of these equations, and we've got x plus y equals -2, and y equals 4x plus 3. Okay, so once again, I'm going to use I'm going to use intercepts for the first one. X plus y equals -2. So when x is 0, y is -2. And when y is 0, pointer here, when y is 0, that drops out, x is -2. So 0, -2, and -2, 0 are both points on that graph. And it looks like -1, -1 would also be a point right there. So we got 3 in a row. So let's get a line through those. Pretty good. There we go. Now the second equation, let's just change our color again. Second equation is y equals 4x plus 3. So think about what method we would want to use to graph this equation, y equals 4x plus 3. Okay, so if you notice that we can just read the y-intercept right off that graph. The y-intercept, I already switched to my tool. The y-intercept is 3, right there. B equals 3. And the slope is 4. So to get our next point, we would go over 1 and up 4. It's a fairly steep slope. And so another point would be right there. And then we can draw the line. Once we have 2 points, we're able to draw a line. Okay, so it looks like those two are intersecting at the point -1, -1. Verify that the ordered pair in part A is a solution to x plus y equals -2. Well, -1 plus -1, that's just plugging it in right into this equation. -1 plus -1 equals -2. And it does. So it checks out for that one. We'd already used that point for that graph there. Okay, let's look. Let's continue looking. So now I want to verify that -1, -1 is a solution to the other equation. So y, I'm just going to substitute right below here. So y is -1 equals 4 times -1 plus 3. So we're asking ourselves that question. So we end up with -1 is equal to -4 plus 3. So it checks out. -4 plus 3 is -1. So this ordered pair right here is a solution to this equation. Okay, so now we're asked about the point -4, 2. We're asked, is that a solution to this system of linear equations? In other words, would it make both equations true? Why or why not? Well, we can just try it. X plus y equals -2 is our first equation. And so if we plug in -4 plus 2 equals -2, it does check out. So it is a solution for one of the equations. So, but we have to try it in the other. So y equals 4x plus 3 is the other one. The y is 2. And is 2 equal to 4 times -4 plus 3. So this is, I'm asking myself, is 2 equal to -16 plus 3? And the answer to that is no. Negative 16 plus 3 is negative 13. So not even close. So no, it cannot be a solution to that system of linear equations. Okay, you're beginning to see the pattern of what we're doing here. So if you'd like to pause the video and go on the next exercise by yourself, you're more than welcome to do that, and then just fast forward and see the answers there. Okay, so we've got two equations. We've got 3x plus y is equal to negative 3. And we've got negative 2x plus y equals 2. Okay, I'm going to transform these equations into slope-intercept because I like graphing by slope-intercept. So I'm going to add 2x to both sides of this equation. When I do that, this part becomes 0. It cancels out. So on this side of the equation, I'm left with just y. And if I write these in order, I can read the slope best. Y equals 2x plus 2. So we can quickly graph that equation in slope-intercept form. The y-intercept b is 2, and the slope is also 2. So we've got a slope of 2. Let me circle tool here. Yeah, so y is 2. I'm trying to get it right on. Yeah, close enough. Okay, and then our slope is also 2. So I'm going to come over 1 and up 2. And that will give us our next point. Okay, and that looks like what the line would be roughly. I got that off a little bit. Okay, that's a little better. Okay, so let's work on our first equation now. 3x plus y is negative 3. So we could either transform this into slope-intercept also, or we can just go ahead and graph by intercepts. So let's do that. Well, for some variety. Okay, so if I let y equal 0, then 3x equals negative 3. So when y is 0, x is negative 1. Okay? Again, if y is 0, then I have the equation 3x equals negative 3. So dividing by 3, I would get x equals negative 1. So that would be one of my points. And then the other point would be my y-intercept. So when x is 0, if I put in 0 for x, this term drops out, and I get y equals negative 3. So let's graph those 2 points, and that will give us our line. So negative 1, 0. Oh, I think I see our point of intersection right now, too. Negative 1, 0 is right there. And 0, negative 3 is right there. And I'll draw our line through there. Right there. Okay, so there's our 2 lines, and the ordered pair where they meet would be the point where x is negative 1 and y is 0. The point negative 1, 0 is the intersection. All right, so part B says verify that, let's write our point again, negative 1, 0. So we want to verify that that is a solution to 3x plus y equals negative 3. So 3 times negative 1 plus 0, is that negative 3? Well, it is. Negative 3 equals negative 3. So that checks out. Yes, it is. Verify that it is, I'm looking at part C now, that's a solution to negative 2x plus y equals 2. So I've got negative 2 times x, which is negative 1, plus y, which is 0, is equal to 2. That's my question. So negative 2 times negative 1 is 2, plus 0 is still 2, equals 2. So it's a solution to both of those. So it's a solution to the system. Okay, now they're asking us again, could 1, 4 be a solution to the system of linear equations? Let's go back and look. The point 1, 1, 4 is on the negative 2x plus y equals 2. It's on the green line right here, but it's not on the purple line. So therefore, it's not a solution to the 3x plus y equals negative 3. So it can't be a solution to the system for the reasons that we just stated. Okay. Okay, we've got another system to graph here. Okay, exercise 4. We have 2x minus 3y equals 18, and we have the equation 2x plus y equals 2. And we're going to sketch those. So both of these are in standard form. So I'm going to graph by finding the x and y intercepts. So when I put in, so first we'll find where x is 0, we'll find the y-intercept, and then we'll find where y is 0 and find the x-intercept. So putting in 0 for y, I would have 2x minus 0 is equal to 18. So x would be equal to 9. So when y is 0, x is 9. I did that backwards. Okay, so let's clear that out. Now when, whoops, let me clear all of that out. So when y is 0, x is 9, and when x is 0, 2 times 0 minus 3y is equal to 18. So negative 3y, 2 times 0 is 0, is equal to 18, and y would be negative 6. Okay, so we've got a y-intercept at 0, negative 6. And we've got the x-intercept at 9, 0 right there. And so we can draw this line. Right through there. Okay, so now let's work on the other equation, which we're also going to graph using intercepts. So if I let y be 0 here, I have 2x equals 2, and x is 1. So 2 times x plus 0 equals 2. So this is 2x equals 2, and x equals 1. So I have the point 1, 0. So we can put that on there. I have the point 1, 0. And then if we let y be 0, no, if we let x be 0, then we have 2 times 0 plus y equals 2. 2 times 0 is 0, so this is just y equals 2. So this would be the point 0, 2. Okay, so 0, 2 is here, 0, 2, and the point 1, 0 is right there. And so let's get the line going through them. This is lots of practice graphing lines for you too, so. Okay, and it looks like we have a point of intersection coming up there, and it looks like it is at the point 3, negative 4. Be the point 3, negative 4. Be our point of intersection. Okay, so 3, negative 4. All right, so we want to verify that it's a solution to both of these equations. I'm going to do that quickly. So we have 2 times 3 minus 3 times negative 4, and I'm asking, is that equal to 18? So we have 6 minus a negative 12, and still is that 18, minus negative 12 is the same thing as 6 plus 12, and that is equal to 18. We can see that. Okay, so it's a solution to that one, and then let's check 2x plus y equals 2. So 2x is 3, 2 times 3 plus negative 4, and is that equal to 2? So I have 6 plus negative 4 equals 2, and that does check out, because 6 minus 4 is 2. Okay, could the point 3, negative 1 be a solution to this system of linear equations? 3, negative 1. So let's look back at our graph. We'll find the point 3, negative 1, which lies out here. It's not a solution to either equation, so it can't be a solution to the system either. Okay, so for part D, 3, negative 1 can't be a solution because it's not on the graph of either line, and those graphs represent all the solutions to those equations, so there's no way it could be a solution. Okay, last example. Okay, so here are our two equations, y minus x equals 3 and y equals negative 4x plus 2. So let's work on this one first. I've set up to find the y-intercept, I'm going to let x equal 0 and see what y is. Well, in this case, if x is 0, y minus 0 is just y, so y equals 3. Okay, and then the x-intercept, when y is 0, or what is x when y is 0, I should say. Okay, so I would have 0 minus x is equal to 3. So this would just be negative x equals 3. And if I multiply both sides by negative 1, then I get that positive x is equal to negative 3. So this would have to be negative 3. Okay, so let's go ahead and graph that equation while we have it. So we have the point x equals 0, y equals 3, that's the y-intercept. And then we have the point x equals negative 3 for y is 0, and that's right over here. And we can draw the line through those points like so. And now we can work on the purple equation. So y is negative 4x minus 2. So the slope is negative 4, because this is in y equals mx plus b. And the y-intercept is negative 2. So let's go ahead and plot that y-intercept. Gives us our first point, -2, 0. Okay, so when x is 0, y is -2. And then the slope is -4. So what that means is for every 1 that I go over, I have to go down 4 and put a point there. So it's another point, okay? And I could even find it by going up the other direction, but I think I'll just go ahead and draw our line now. That's off. Okay, so there's the second line, and we're going to be asked what the point of intersection is, so we might as well look at it now. So the point is at -1, and the y-coordinate would be 2. Okay, so we've got the x-coordinate of -1, the y-coordinate of 2 is where our point of intersection is. So -1, 2. And we're going to put those values into the first equation. So y is 2, y minus x, 2 minus a -1, is that equal to 3? Well, it is, because I can change this to 2. It is 2 plus +1 equals 3, so it checks out. And then this next equation, we'll go ahead and plug in the 2 for y and the -1 for x and see what happens. So we've got 2 is equal to -4 times my x-coordinate, which is -1, minus 2. So we've got that 2, this is our question mark, is -4 times -1 is 4, and I still have -2, and so that checks out. 4 minus 2 is 2, so that's equal. Could -2, 6 be a solution to the system of linear equations? Would it make the equations true? -2, 6. So let's look at -2, 1, 2, 3, 4, 5, 6. So it looks like it's a solution to y equals -4x minus 2, but it's not on the graph of y minus x equals 3. Okay, so once again, you can write something to the effect of this. The point -2, 6 is a solution to y equals -4x minus 2, but not to y minus x equals 3. Okay, so I want to go back and look at each of these pairs of intersecting lines. So these two intersect. In fact, all of our lines intersected in one point. So is it possible for a pair of lines to intersect in more than one point? Think about that. And I guess I should actually say, is it possible for two lines to intersect in something other than exactly one point? Those two intersect at one point right there. Okay, so pause the video, think about that for a minute, and then come back. We'll keep talking. Okay, so if you thought about this, if I have a line and then another line, I could put that line even like that and have them still intersect at just one point. So that's kind of the takeaway here, is that two lines in the plane will intersect at a distinct point, and that would give give the system of equations that these lines represent one solution. Okay, so what's the only way that lines can intersect at something other than one point? Well, if you think about it, if two lines have exactly the same slope, that means that they're parallel. And the definition of parallel lines is that they're never going to run into each other. No matter how far you go, they won't have a solution. So this idea that these two lines generally are going to intersect in one point. Okay, so exercise 6 is optional and the answers will vary, but you are challenged to write two different systems of equations with the point 1, -2 as the solution. So some strategies you might try would be just to start with the grid, start with your grid and solution, and write some equations off of that. Or you could just start plugging away, and if I wanted it to fit into, say, this equation, 2 times x plus y equals something, I could put in my point 2 times 1 plus y, which is -2. Ooh, that equals 0. So for 2x plus y, I could have the equation 2x plus y equals 0. And then I would need to find another equation that had 1, -2 as a solution. Okay, so that's your challenge to work at on your own. And right now we're going to just quickly go over this lesson summary of what we've seen in this lesson. So when the graphs of a system of linear equations are sketched, and if they are not parallel lines, then the point of intersection of the lines of the graph represents the solution to the system. Two distinct lines intersect at most at one point, if they intersect. The coordinates of that point, x, y, represent values that make both equations of the system true. Remember, they both have to be true at once with the same solution for it to be a solution to the system. Okay, and so this diagram here is just showing you two equations who are intersecting at 4, -1, and how they're checking that. So I think that you are so ready for the exit ticket and problem set. So have good luck, and we'll see you back here tomorrow for lesson 26.